it here? Units of learning, induction. Okay, if we go investigation. Hello? What's happened to everybody? I'm feeling unloved. We're missing. Eden, where are you? Iman, I had heard this morning.
Iman leaving. Oh, she was leaving. Wi-Fi. She went home sick, I think.
Iman. And Belle's already talked to me. That's right. Anyway, so if you want to have a look, the task is here. And, if you have a little bit of time, this is what you want to try and start getting ahead of the game, right? Oops, here it is. It has to finish, Bobby's telling me, right? It has to finish downloading. While we're waiting for it to finish downloading, you don't have to. How do you know that?
It starts like the blue bar around this.
Scary little mosquito there. So the first part starts off quite nicely, but again, you do have to fiddle around. So as you're playing with GeoGebra, you have to come up with the room. Okay, so make and start thinking of your dimensions about your room. Mask. Last week, man, come on. Okay, you have to come up with the centimeter, whereabouts it is. Do you want to have one person? Do you want to have two people? Okay, where's it going on the person? Is it going for their ear? Is it going for their ankle? Don't make it go to the same spot is my suggestion, but you don't have to do that. And then part 2 is you're introducing the mosquito. So you can start doing a little bit of research yourself. I just looked at speeds of mosquitoes. Okay, so think about what that's going to be. So you're allowed to get started, play with the software. That's quite nice. But please do have a look. All right, so that is in your class notebook. You've got, I haven't put stuff in there, but investigation, you can have a look. All righty. We just said Mac is, your recorder is clear. So we said Mac is in our bad books, or mine, because he said the other day, yes, Mac said this, that his teachers never taught him about simultaneous equations. I know. Bobby taught him about simultaneous equations and like, seriously? How to do it on the calculator, he did not know. Shh. So, I'd like to think that yes, something like this, and in fact we can look at the one that they've done as an example. Right, you've got our solutions here, 2, 4 and minus 1. If they didn't ask you, can we do that quietly, guys? If they did not ask you to do it using row ops, we all know you can go into equation, yes? Simultaneous. How many unknowns do we have? 3. And then you just put in 1, 3, minus 1, 15, and etc., etc. Press solve and you'll get your answers. We practice this, right, with row ops where it has nice answers because eventually you're going to get letters in there. So we need to practice that again. Oui? So let us dive in. I'm hoping that will be fine. We remember this. We'll get to the different sorts of solutions and all that sort of stuff. I think we just sort of played around last year. Did I talk about the actual planes? I mean, so we were just looking at these equations, and we're just going, they're just equations. That's it. But now we realise that when we've got ax plus by plus cz equals a number, that actually represents the equation of a plane. All right. So when we now look at these, they're actually planes, and we have, look at them, so many, eight situations that could happen. Okay, now we can have, they're all coincident. So what would it be if they're all coincident? What would that look like? what would the equations look like? So can you give me another,
Multiple equal.
right, be a multiple. So the coincident one for this would be 2x plus 8y plus 22z equals 14. Correct? So if we had 3 of them, all multiples of each other, bang, coincident, we've got to say there's infinitely many solutions. Correct? And when we did the row operations, we just get lots of zeros everywhere because everything would cancel. So that's one. How would we know that 2 planes do not meet at all? So they are parallel to one another. Same, so 1x, 4y plus 11z but equals 8. Right, so they've got the same normal vector, but then they're shifted. So when they're parallel, no solution, not going to happen. You'll get funky. You might end up with something like 0 times z equals 4. And you go, well, that's impossible because 0 times anything has to be 0. Okay? Yes, all coincident. You can have where they intersect at a line. Yes. When we look at part 4 and part 6, where you can see 2 lines intersecting, you can go, all meet at one point. Yes, we can do that. Sorry. Question 8. System 8, where they all meet at 3 different lines. You can see that's a possibility. We will not be solving anything like that. The only thing we'll be looking at is when they meet at a unique point or when they meet at a common line, whether it be like 7 or like 2 and only one line. Okay, that's we limit it to that. And of course, if they're coincident. All right, so we'll remind you about how those go. Yeah, shall we dive in? Where are we going? J, did I skip one? So let us just remind ourselves of how we do our row ups. I don't think we have to do them all. Shall we just do A? Wait, let's see. 6J. Okay, how about we do A? Oh, let's do, I want to do A, B, and D. Let's do A, B, D. Let's go. And I've already got A here.
Why don't you do C as well?
Unnecessary. If you want to do all of them, you can do all of them.
I mean, you got 3 or 4.
Yeah, sure. So, 1. Remember, what's some of the tips? If you can, have the 1 up the top, right? Just because, Mac, come on, seriously. Just because that is your first equation there, it doesn't mean you have to put it as your first one. You're allowed to shift them around, all right? This is called Augmented Matrix. And who can remind us of the game plan? What is it that we actually want? Right, we want to make this one be a 0. We want to make this one be a 0. And either one of these, but hopefully it'll be that one first. Okay? So, away we go. Your notation is incredibly important, so do not skip that. Okay, so we've got row 1, we've got row 2, we've got row 3. People are still writing, so I'll just pause for a minute. Why did it just do that? Want to get a 0 here. So I am going to say, instead of row 1, take row 2. I'll be a bit tricky. I'm going to say row 2, take row 1. Anyone want to know why? Or tell me why? Because I can see positive. So 1 take 1, 0, 6 take 4, a 2. 17 take 11, a 6. 9 take 7, 2. Now if you went row 1, take row 2, you're not wrong. But you would then have minus, minus, minus. Yeah? Right. And then I'm going to have row 1 take row 3. I know you are consuming a fair bit of paper, but I would also make it's an argument. You might go, oh no, I'll leave it as it is because I still get the same answer. But if you really wanted to, we could simplify this and say that's 1, 3, 1, correct? But you might go, no, I don't want to do that because I don't want to have to write out another box, and I'm sure on paper. Up to you. And we've also got 0, 0, 1, 1. Again, this is unnecessary. Because I didn't make it a 3. And so therefore, we end up with 1z equals 1. What do we do next? Sub back into up here. Okay, so it would now be y plus 3z, which is 3, equals 1. So therefore y is minus 2. And then we sub to get x. So I'll be quiet now, but do B. But do you need me to finish at x? You're all looking at me, right? You're all looking at me, right? We'll go x plus 4y. So 4 times minus 2 plus 11 times 1, which is 11, equals 7. Have I stuffed up? Okay, so you get ahead of the game. Let's have a look at B. Come on. If an old 50-year-old beats you, you're going too slow. Come on. I don't know why my thing is acting up today. I'm not convinced it's recording. Like even here, what do you notice about this one? It's all multiples. So, I mean, even before, you could write that down as a half because then you're just dealing with smaller numbers, I think. Yep. So you could, so this would be x take 2y plus 4z, equals, no, that's not right, there's a 1 there, right, and then absolutely with this one you could divide through by the negative and that could be 3x, take 6y, take 7z equals 3. Now, you know, just remember the more that you fiddle, maybe there's more likelihood that you might forget a negative or not switch all the signs, but it's up to you. I've already written this, but should you want to write it as divide by 2 or not? As soon as you start having to times one row by something and subtract, then can you please have somewhere nearby you're working out, not just for my sake, but for your sake, for when you need to find an error. All right, and don't have them scattered all over the shop. Try and be as neat as you possibly can. I think it's at this point we say Ethan, well done. You are writing bigger. Thank you. Absolutely. Well done. Sorry, that was me having a lollipop. I haven't left myself room, so I'm just going to do it here. Were you okay out there? I mean, I can talk to you as I go, but I just figure you know what you're doing. You've done it. Oh, well, carry on. Yep. Okay, so this is the bit where we have to have a little bit of a reminder here. I've been a little bit naughty, I haven't written my row ops there, but basically I've just divided by 2, divided by 22, and you can see that now. If I keep going, what will happen is if I subtract these 2 rows from each other, what happens? We get 1 minus 2, 5, 1, 0, 0, 1, but then if I subtract, we get 0, 0, 0, 0, so the whole row disappears. So what's going on there? It means that this is where they can intersect at a line. We can have some infinitely many solutions. I was just checking them, right? So we have a look, and this is when we have to go, well, Z or Y, whatever it could be, anything. Now, I can see up here, we've actually got a situation where I go, well, Z actually has to be 0. Would you agree?
Yeah.
But then we go, well, what on earth is T? Well, this is when we could say, well, let Y be T, and therefore X will be 1, take 5 times 0, which is 0, plus 2 times Y, so plus 2T. And that, my friends, is the form of a line in space. So if these are our planes, we've got a line. Now, I went back to have a look to go, could it be that we've got 2 planes squished together and 1 cutting through? So it just cuts out 1. So what would it mean if 2 were coincident? They'd have to be multiples of? Are there multiples of anything there? Is one parallel with the other? So it doesn't, but no. So this is like just a freaky. We leave it like so. But I don't think they'd ask us to give geometrical significance. So it's at this point when we have our summary page. Let's just make sure that we add to that. So when the last row right, we're talking about the last row here. If we get it down to 0, 0, something, let's give one. I mean, I can put lots of letters in there, but it's going to drive you insane. But let's say we have 5. I shouldn't have gone 5. I'll go 15. Could I have gone 5? No, I can go 5. 5, 10. Right, we would then say, ha ha, Z could equal 2. So this would be, we've got a unique solution. And this is making a big assumption that we haven't got 0, 0, 0, 0 in the line above. Or, it's not like we had before where they're exactly the same. Okay? Then, what if we have 0, 0, this is the best one. What happens if we had 0, 10? What's going on there?
No solution.
No solution, because what this is actually saying is you've got 0 times Z equals 10. And we're going, hang on, that can't happen because 0 times anything is 0. So this one is a big old no. Okay? Now, one of the things that gets me, and I think always just double check this, because what some students do is they will go 0, 0, 5, 0. They go, oh, there's a number and there's a 0. Must be no solution. Can you always double check? Because we can have here 5Z equals 0. Doesn't that mean Z equals 0? And then we can go back and find others. So this is also unique solution. So this whole thing here, right? Because that number could actually also be 0. Agreed? Okay, and then of course we've got the very last one when if the last row is 0, 0, 0, 0, well that's when we have to let t equal, let Z equal t or let Y equal t, get t's involved. And that's when we've got the possibility that the planes will meet at a line. Okay, so we're talking about, sorry, if you were writing that down, we're talking about things like this. You can see there's infinitely many solutions that keep on going where they meet, not just in one unique spot. Make it the sense? So you really love it when this happens, provided you've done all the right steps, because then you don't have to do anything else. It's a little bit of a pain when you get 0, 0, 0, because then, oh, let t equal, and then sometimes you have to go back and they could be fraction answers. That sucks. But anyway.
Is there a scenario where, I'm going back to the diagram.
Back to the diagrams. Yep.
Where I think it's the bottom right one, where you get one like that. Like somehow with that occur and roll.
So for 8, if it came up somehow for that, we'd end up going, no, you wouldn't get a solution. Like it just doesn't work.
Okay.
You wouldn't get that. So there's no big surprises because I just went there. But do you want practice? If you want practice, then C should be a unique solution and D is going to be no solution. So we're expecting that it goes down to 0, 0, 0. So I guess we could do that. Or, hello, we get more practice and here we go again. Don't worry too much about that. Under what you can have a read of that one we've discussed. Solve the following using elementary row operations. Now, what's going to happen is because you've got 2 bits of information but 3 unknowns, what will happen? you get the t's involved right from the get-go. Because basically your bottom row is 0, 0, 0, because you're just missing it. So for all of these, you're definitely going to have a t, or it'll just not work at all. There will not be a unique solution, okay?
So it's 0, 0, 0, t.
So, no, so let's do it. Let's do it. Did you guys want to practice the early ones, or you think we want to dive straight in?
Maybe do one.
Okay. Of this, or the one? Oh, okay. Give you a moment. Why? Hasn't done that all day. So, with these ones, you've got only 2 bits of information, but 3 unknowns. So you do the same thing. You would try and get a 0 here, right? And then, well, might as well just do it here. So what will I do to get a 0 here? 3 row 1 minus row 2. So we go 3 minus 9, 6. Oh, what am I doing? 8 3s, 24. Geez, have to think about that. So all agree? All aboard? All agree? So we end up that, yes, Z equals 5. But isn't this just like the question that we did before when we did have the 3, but the rows cancelled each other out? We got the 0, 0, 0. So it's just pretty much the same thing where we don't have the Y and we can't get it. So that's when we'll say, okay, well, Y... and you're going to be a T, man. T, man. Mr. T. So, and now we can get X. 8. Take 10 plus 3Y, which will be the 3T. So X is negative 2 plus 3T. Yeah, yeah? Yeah. They could be really mean. I can't remember because we skip these sometimes. But if this all cancelled out, then go again. Have a look at your equations, because if they all cancelled out, it would mean that it's a multiple of